Hello, my name is Alex Albani. I'm a professor of architecture at the American University in Dubai. I'd like to thank the conference organizers, AMPS, Routledge, and the Czech Technical University for this opportunity. The title of this presentation is From Architecture to Cinema, Reverse Engineering Landmark Films with BIM. The idea for this research comes from one of the semester projects we do in Architecture 294, Film and Architecture, and that is the architectural contextual analysis of classic films. BIM, or Building Information Modeling, as a form of representation, was never really in the picture when I first started teaching this course about 3 years ago. As the course evolved and as I could see the students get deeper into the architectural analysis of films, the question of architectural documentation in film planning and production became very intriguing. The research question became, what if BIM had existed? Would the film narrative have been different, and how? To answer this question, we started using Revit as the BIM solution to reverse engineer key architectural scenes from landmark films that were produced before BIM technology became available around 2002. And the three student case studies I'll be sharing with you today in this presentation are Metropolis, a 1927 German expressionist science fiction silent film directed by Fritz Lang; Playtime, a 1967 satirical comedy French film directed and co-written by Jacques Tati; and Blade Runner, a 1982 science fiction American film directed by Ridley Scott. The importance of this research lies in how crucial architectural documentation is to both disciplines. Just as BIM has fundamentally transformed the practice of architecture, I believe it holds similar transformative potential for BIM. The contribution this research makes is to advance the mainstream adoption of BIM as a framework for architectural documentation in film planning and production. The BIM equivalent technology per se does not exist for the film discipline yet. For the time being, it is just the use of BIM in a non-conventional way. This is the outline for this presentation. We start with a brief historical context of BIM and highlight how BIM has fundamentally transformed how architects represent design and construction, shed light on current workflows in how filmmakers document architecture, touch on the architectural analysis of three landmark film case studies, and highlight how potentially BIM, in addition to AI, could have changed the narratives of these films. And finally, conclude this presentation with findings and possible progression of this research investigation. In terms of historical context, BIM as a premise emerged in 1998 and as a software application in 2000. In 2002, Autodesk acquired Revit and fundamentally changed how architects represent design and construction. Architectural representation, however, can trace its beginnings to ancient Egypt and was in the form of manual drafting, sketching, and color pencil rendering back then. This form of practice lasted till the mid 1980s. Buildings then were becoming a lot more complex, engaging larger teams and integrating newer disciplines such as electrical and mechanical engineering. CAD, or computer-aided design and drafting, became available in the early 1980s. Architects managed to transition within a short period of time, and by the late 1980s, CAD became mainstream in terms of architectural representation. This, however, did not fundamentally change the profession of architecture. CAD brought about some time and cost efficiencies, but it did not do away with increasing discrepancies and errors when coordinating other building components, such as structural engineering or mechanical, electrical, and plumbing engineering drawings related to architecture. Representation was still very abstract. Change management was becoming very costly and time-consuming. A change on a given drawing had to be manually changed as well wherever it was cross-referenced in the possibly tens of other drawing sheets uh, related to the discipline of architecture uh, and the disciplines of structural engineering, mechanical, electrical, and plumbing. All these limitations and inefficiencies of CAD-based workflows drove architects to seek more integrated and intelligent design tools. The premise of a change is a change. The premise of a change anywhere is a change everywhere. Emerged then in 1998, and by 2000, this new form of practice got to be known as BIM, or Building Information Modeling. Terms like bidirectional associativity and embedded relationships became synonymous with BIM. The whole idea was to model intelligent buildings with real lifelike parametric data in 3D and automate change management. BIM resulted in huge time and cost efficiencies. It was a revolution in how buildings are designed, built, maintained, and even demolished. The subject became extensive over time, that new subspecializations to this new form of practice emerged, such as 4D BIM, 5D BIM, and so on till 10D BIM today in 2025. In terms of architectural representation workflows in film, they are basically in they are today in 2025 where they were in architecture pre-BIM in the 1990s and earlier. Traditional film planning depends on planning sets, props, and spatial arrangements to support the narrative and aesthetic goals. The process is very fragmented and relies on less formalized usage of different tools, from manual and CAD representations to physical scale and digital CAD models. It is identical to pre-BIM transformation, where architectural documentation was never 100% accurate, never 100% complete, and never 100% coordinated. The first case study we used to carry out our investigation was Metropolis. The film architectural elements combine industrial, brutalist, and deconstructivist elements alongside surrealist futurism. The architectural styles range from Art Deco and Bauhaus modernism to expressionism with strong Gothic undertones. The skyscrapers in the upper city symbolize elite dominance and control, contrasting with the oppressed workers in the lower city. The city prominently features a new Tower of Babel. Its vertical structure is visually its vertical structure visually communicates class hierarchy and power dynamics. Upper City, depicted as utopian, is luxurious, bright, and technologically advanced, with glass and steel architecture emphasizing cold efficiency and emotional detachment of the elite. The lower city, also known as the worker city, is shown as dystopian, dark, brutalist, and claustrophobic. Architecture here is starkly utilitarian, reflecting oppression and industrial exploitation. Overcrowding and density in the workers' lower city are visual metaphors for social inequality in the film. Architectural symbolism extends to lighting as well. Upper city brightness conveys technological uh, prowess and societal power, whereas the shadowy lower city conveys exploitation and oppression. Staircases, elevators, and vertical transitions symbolize rigid social hierarchy and restricted mobility of lower class workers compared to elite freedom. Massive architectural sets and detailed miniatures blend Gothic, Bauhaus, and Art Deco elements, create a visually immersive and technologically ambitious urban landscape. What if Metropolis had used BIM? If Metropolis had been developed with BIM, every architectural element, from the soaring Tower of Babel to the lower catacombs, would have been embedded with metadata. All rooms, for instance, would have been accounted for, all materials specified. Circulation flows planned digitally, even simulated crowd movement would have been taken care of digitally. The disparity between the upper and the lower cities could have been quantified and visualized, not just symbolically, but in measurable terms. BIM could show, for instance, that upper city dwellings receive 6 times more natural light and 3 times more better air quality than the underground workers' dormitories, turning metaphor into measurable injustice. BIM allows for as many design options to be generated, which could have opened the narrative to alternative futures. What if the Tower of Babel had been designed as a civic tower, for instance, rather than a corporate citadel? What if Rotwang's lab had been subjected to a zoning review, and so on? BIM also enables architectural storytelling to evolve non-linearly, so basically spatial fiction through parametric alternatives. In the case of Playtime, the film's true protagonist is the city itself, Taddyville, a fabricated modern international urban environment. It dictates how characters move, behave, and interact, functioning as a maze filled with glass, steel, and concrete. It evokes feelings of disorientation, sterility, and mechanization, reinforcing the theme of alienation in modern urban life. Both the architecture and the people's clothing conform to a neutral, impersonal aesthetic. The architecture's supposed efficiency, seen in elevators, cubicles, and corridors, actually complicates navigation and daily life. The design language prioritizes order and logic but results in dysfunction. The director constructs a city where the indistinguishable hallways, modular spaces, and uniform elements form a confusing maze-like environment. This spatial ambiguity symbolizes the difficulty of forging meaningful human connections in a mechanized world. What if this landmark film had used BIM as well? Playtime thrives on spatial ambiguity, maze-like corridors, indistinguishable facades, and a uniformity that generates alienation. BIM fundamentally, however, enforces a clarity of design intent. Each building element carries embedded metadata related to material, to function, orientation, relationships with other components, etc. A BIM modeled Tattyville would not intentionally permit spatial ambiguity. BIM would undercut the film narrative intentional disorientation the director uses to satirize modernism. BIM here may have been an overkill. Glass in the film is used symbolically to create invisible barriers and visual confusion through reflection. BIM, on the other hand, enables material simulation. Rather than a symbolic critique, the film could evolve into an examination of how excessive use of glass and modernist transparency fail the inhabitants in terms of health, safety, and overall well-being. BIM here could have reinforced their narrative in a way that could not have been possible. The film portrays characters to behave awkwardly within rigid environments. They stumble, collide, and fail to engage meaningfully due to spatial inefficiencies. With the application of BIM and the integration of AI, one could model human circulation and identify architectural failure points where congestion or confusion arises, allowing for different satirical scenarios to potentially be considered in support of the narrative. The sameness of modern architecture in the film leads to a loss of human and urban identity. The parametric nature of BIM allows designers to reproduce typologies at scale. It allows controlled variation within the parameters that can both standardize and differentiate, highlighting that loss of identity is not merely a result of repetition, but of intentional design choices. Blade Runner is the third case study we looked at. Its 2019 city of Los Angeles in California presents a dense, decaying, and hyper-vertical metropolis dominated by neon, rain, pollution, and oppressive architecture. The city is both a character and a narrative force. The film uses modernism, postmodernism, and futurism, emphasizing verticality, density, and darkness. Streets are narrow, chaotic, and cluttered, reflecting the collapse of public infrastructure and the decay of civic order. Tall skyscrapers signify social classes. The elite occupy high towers while the masses live in congested, degraded zones below. The city is culturally presented as a hybrid, reflecting the realities of globalization. Signage in Japanese, Chinese, and Arabic are all over public spaces. Asian and Middle Eastern music heard in the background in street scenes reinforce the sense of a transnational dystopia. If Blade Runner's cityscape had been conceived through BIM, the data-driven hierarchy of the model would allow each building and zone to be embedded with metadata on ownership, material sourcing, environmental performance, access restrictions, etc. A substantial narrative shift is possible here because buildings could then be interrogated to track human replicants through their interactions with the built environment. BIM's parametric control parallels the Tyrell Corporation's genetic programming of human replicants. In both cases, systems of total control, whether over buildings or bodies, is central to the film's narrative, and BIM here would have amplified potential scenarios to consider in support of the narrative. BIM would make urban inequality visually quantifiable in this classic film too. What if Tyrell's headquarters wasn't just monumental, but a LEED Platinum certified building? Would BIM expose the greenwashing of corporate architecture? In the film, scenes could be navigated through BIM viewer environments and not shot traditionally. Alternative storytelling would make use of a digital reconstruction of the city, filtering spaces by access rights, lighting parameters, or surveillance overlays. BIM perfectly aligns with the film's questions. What is real? What is a copy? Just as replicants pass for humans in the film, BIM models simulate real life like environments. Integrating AI in in BIM film set design is not about replacing set designers or cinematographers, but rather about augmenting creativity and amplifying possible narrative scenarios. It can speed up ideation to visualization workflows. It can automate spatial and geometric optimization. It can reveal inefficiencies in architectural documentation. It can eliminate missed architectural opportunities in support of the film narrative. Integrating BIM and AI not only enriches how we reconstruct cinematic spaces, but also empowers speculative what if scenarios, reimagining how these landmark films might have looked for or functioned within generative intelligence guiding design decisions. In conclusion, BIM reconstructions can reveal architectural and narrative layers that traditional film documentation often conceals. BIM can ensure dimensional accuracy, scale fidelity, and symbolic clarity in the spatial storytelling. AI integrated BIM tools can enable rapid exploration of aesthetic and logistical variations, for example, camera blocking, lighting strategies, and alternate spatial moods. BIM can also facilitate a shared visual language among directors, cinematographers, production designers, and special effect teams. All stakeholders can view, annotate, and iterate in real time within a BIM coordinated model. Reverse engineering with BIM enabled a new kind of cinematic analysis in Architecture 294 film and architecture, one that is spatially precise and analytically rich. The three film case studies we looked at across different eras and aesthetic ideologies revealed how BIM could decode social stratification and vertical control in Metropolis, repetitive spatial patterns and bureaucratic absurdity in playtime, hyperdense, hybridized urbanism, and cinematic atmosphere in Blade Runner. The suggested next step in this investigation is to use VR and AR and to explore BIM reinterpretations of these classic films in real time. Big thanks to my students in Architecture 294, Film and Architecture, to the American University in Dubai, and to the conference organizers, Routledge, Czech Technical University, and AMPS. Thank you for your attention. My email is aalbani@aud.edu. Thank you.